Good afternoon, everyone. Today, I'm going to present my sensor letter paper on the topic of powered passive resonant based omnidirectional sensing system in human cooperative robots. Human cooperative robots is a field where the humans and robots are working together, and we are propose the system for the safety purpose. So this is the introduction of the system. You can see there is a multiple robots are working, and this system is powered by surface wireless power technology. It's a novel wireless power transfer technology, and in this system, if the human in the proximity of robotic arm stop working, we can program this proximity by this voltage strength of this RF source and also with the resonance frequency of this coil. And the problem statement in this field, the placement of sensor, you can see in other journals is a different. Some people are place the cameras there, and some are the IR based sensors, and some are the putting below the robotic arms, and some researchers are proposed the putting sensor on the human body. So these are the trade-off: cost, implementation, and integrability, digital system and battery-less system, and power consumption, and multiple receiver powered with a one transmitter in the wireless system is again challenging, and the proximity range and omnidirectionality. So we propose a RF-based coil for the sensing, and this coil placed at the this end of the robotic arm, because this is a mostly movable arm of the robotic arm. So we want to put one coil on the one robotic arm, and this is powered through this surface, and this can power up to multiple coils in the when this arm is working. This is the passive state and is not consuming very high power. It can consume only power in nanowatt range. When some human body come in the proximity, starting conducting, and this coil going on resonance of the surface and starting power up the system, and we are using RF to DC converter. It converts the RF signal to DC and provide a 1-bit digital signal. We are using LED to verify this operation, and with the human hand this bandwidth will increase and the quality factor of this coil is getting down, but it is higher enough to amplify the at the SRF. This coil act as a amplify the voltage. At the top end we are getting very high voltage and very less current, which is suitable for the digital systems. And this is the implementation of this is the system, and we are using multimeter for the checking the average current here, and we are putting a RF below this the wooden pad, and this is the powered with the RF source. We are using a function generator to power up because it's require very less power, so function generator are enough for the multiple receiver and the heavy loads. We can use the RF source with the high power and the power amplifier after the RF source. Then this system work anywhere on the surface and also above the surface, because it can amplify very small signal, and on the surface we getting the 0.15 watt and RMS value, and for the input we are providing 10 volt on the coil. But if we are moving, and we can see this receiver starting consuming power, the surface power is reduces by the 7.74 dBV. And I'm concluding this session. In the passive state, it's consuming nano amperes power, and the inactive state, it's consuming very less power in the microwatt range, and the RFDC converter and other things decide is SRF. So we can design it using one simulation software HFSS and implement it using a coil, and this is a very less expensive system. I'm making it using a passive component. You can see this demonstration. It's a 3.6 megahertz, and we are providing it to below this wooden surface, and this is our coil. And when human body come near this is starting conducting, and this is providing current to this LED, and it's working above the surface up to a certain range, up to 15 centimeter. If we are providing more high power, it is working more than this range also. Or it's omnidirectional, so it can detect the human interference from all direction, from every side, and also above the coil. Any question?